Okay, all right, thank you. So just very briefly about me, I am a principal developer advocate at Temporal. I've been with the company just under 4 years, but I've spent most of my career as a software engineer, and the problems that Temporal solves are problems that I've faced as a software engineer. So I'll begin with what is Temporal. Temporal is an open source durable execution platform, and this raises the inevitable question, what is durable execution? The best way to understand this concept, and this concept will change the way that you view programming, is to see it in action. So here I have a simple program in Ruby that just counts from 1 to 5. So there's no temporal here. This, oh, yeah, okay, sorry.
Or did you want that separate screen?
Yeah.
You want to see what's on your laptop?
Yeah,
Okay.
yeah. Whatever's on my laptop should be back there. Yeah, maybe that super bright light could go off. Yeah. Is there a way to dim that or something? Because I don't think people can see very well. Like the one that's in front, maybe.
It's better than yesterday.
Okay, well. Well. Okay, can you see it back there? Okay. Okay. More to the right. All right. I feel like I'm being messed with. Okay. So here we have a little bit of code. This just counts from 1 to 5, right? Simple Ruby code. There is no temporal in this at all. So when you run this code, as you would expect, it counts 1, 2, 3, 4, 5, and it sleeps for 1 second in between. So, and then it exits. So if I run this, and let's say right there, after it counts to 3, the program crashes. And there's a variety of reasons why it could crash. It could be a bug that's in the code. It could be a bug in a library dependency. It could be a kernel panic in the operating system, a power outage, your machine gets rebooted during execution. It could be a hardware failure. Lots of things that can cause your application to terminate prematurely. And so when that happens, well, let me ask you a question. When I run this again, what numbers are going to print out first? 1. And you know that because you know how computers work. But if you go ask a non-technical person, think of like, I don't know, your plumber or your cousin or somebody that doesn't work with computers every day, they'd say, well, it's going to print out 4 because they're telling you how computers ought to work. And I'm here to tell you computers can work that way. And what we're talking about there is durable execution. So if I run this, which does have durable execution, it prints out 1, 2, 3, and then I kill it. But what's going to be different here is that you'll see when I start it up, the next number it prints out is not 1, but 4. And the reason it's able to do that is because durable execution ensures that your application does not lose state. Even though the process exited, it's able to resume execution in another process. And it can even potentially resume that execution in another process that's running on an entirely different machine, so it can survive hardware failure. And that's a simple concept, but it changes the way that you view software development because we are conditioned as engineers to think about failure. My wife thinks I'm a pessimist because I'm always thinking about what could go wrong. She's like, well, let's go to dinner. And I'm like, well, what if it's too full? What if, the road's closed or, any number of things could go wrong. Temporal and durable execution allows you to regain not only the happy path for your code, but the happy path for yourself. And so that's what durable execution is all about. So I just did the demo. Durable execution is crash-proof execution. Temporal is an open source durable execution platform. It automatically maintains the state of your application, which enables your applications to recover from a crash as if they never even happened. So you don't even have to write all the code to sort of take the variables that you've assigned within your application at runtime and stuff those in a database so that if your program crashes, you can recover by loading them back from a database again. You don't have to do any of that. The value of your variables is persistent, and so you don't need an application database anymore. It provides built-in support for retries because you're going to you're going to inevitably work with other systems that don't have durable execution. You're going to need to call some other service that crashes or it's down, or you're making a call over a network that goes down, and you want to be able to retry automatically, and Temporal provides that. It also provides support for timeout, so you're not waiting forever for a response that may never come. It makes your applications more reliable, but more importantly, it makes you more productive as a developer because your code is not littered with trying to rescue from these problems that occur. You're able to think about the happy path instead of everything that may go wrong along the way. And that makes your applications faster to develop and also easier to write, easier for other people to understand, easier to scale, and easier to support. So I'm going to show you some examples of this. But most importantly, Temporal is open source. There's two components of Temporal that you will use. One is the SDK. That's available for a variety of languages, for example, Java, Go, Python, PHP, TypeScript. And recently, last month, we added support for Ruby. So you can develop applications that use Temporal that are written in Ruby. And you can actually mix and match these languages. So Temporal provides for polyglot programming. So if you need to write something in Ruby, but you're interacting with another team that wrote the stuff in Python, it's possible to do that. So Temporal is open source, MIT license, so it's a very permissive license. You can use all of it without any cost at all. So you could think of it like the Apache web server. You can download that, you can run it on your machine, and so you may say, hey, you have a nice booth over there. You're giving away a gift card. How did you afford all this? The way that we make money is because we offer a cloud service that is an alternative to running Temporal service on your own. So in the same way you could run Apache web server on your own machine, you may decide you want to devote your energy to building websites and not to being system administrator, so you can have a web host that does that for you. And it's the same idea with Temporal. You can use all the software for free. If you don't want to be a system administrator, if you want somebody else to take care of the management of the Temporal service, we offer that through Temporal Cloud. But the choice is yours. You can move from self-hosted to Temporal Cloud, but you can also move back the other way. So that's it. So we've got a bunch of free resources, free training, tutorials, lots of other stuff on learn.temporal.io, but I want to show a few more demos, and I love Temporal so much, so don't let me get sidetracked and forget to announce the giveaway that we're going to do at the end. And so first I'm going to begin with a happy path, and so here we have, actually, wrong terminal there. I'm going to start this service, and I'm going to show you a money transfer example, a classic example that we use for demonstrating Temporal. And the idea is we're going to move money between two accounts. So think of PayPal or Venmo or Zelle or something like that. And so this is what it looks like in Temporal. And so we have the workflow, and don't be scared by the term workflow. Like, there's a lot of baggage with that term. In Temporal, a workflow is just a function or method that has durable execution. It can survive a crash. And so let me bump this font up. Whoa, maybe not so much. And so this particular workflow is orchestrating two operations. One, we're going to withdraw money from the first account, and two, we're going to deposit money into the second account. We want to make sure that both those things happen, and they happen exactly once. And so that's the idea here. And then the implementation of those, the withdraw and deposit, is over in a separate file. And so these are just functions that we're just going to print out a message. We're not actually going to call in this particular demo. We're not going to call a banking service, but we absolutely could. And so this is what is going to happen. So I'm going to show you the happy path here, where everything goes according to plan. And so Alice is going to send $100 to Bob, and Temporal provides a web UI so you can see exactly what took place during execution. So, oh, by the way, when we did the counting, we can see exactly, there's the timeline. We counted 1, 2, 3, 4, 5, and that long delay is where the thing was down. Let me show you the money, though, money transfer. We can see the input. We can see the result. We can see the sequence of events. Here's where the withdrawal was scheduled, started, and completed, same with the deposit. And down here we can see an entire set of events that detail what took place. So you can see after the fact what your application did at runtime. And so that was the happy path. Everything went according to plan. But let's say, for example, that the network is a little flaky. So we're going to try this again. And I've coded it so that if it's Antonio sending money, that we experienced a little flakiness here. And so the withdraw is, you can see it says attempt 4. And this red dashed line indicates that it's failing. And if I click it, it'll show us, oh, it's connection error for bank. It happened so quickly, but the connection error. So the failure, we can know like what was going on, and it'll direct us to exactly the line of code that's failing. And then when that problem gets resolved, the network outage gets resolved, the thing completed with no interaction on my part, as if it never even happened. But I can still go back if Antonio says what was going on. I can go back and look and see that this succeeded on attempt number 5. And the error that took place was connection error for bank API. So I have insight to things that happened in the past through the Temporal Web UI. Okay, so another demo is, let's say that we're going to have Arnold send Bob $300. But the problem is Arnold only has $200 in his account. So there's something that we don't want to retry again and again because he doesn't have enough money. So we can designate certain types of errors as non-retriable. And so this is what in the code up here, I say non-retriable error types. And so if you have an invalid account, that doesn't get retried. If you have insufficient funds error, that doesn't get retried, but a connection failure would get retried, or anything I didn't list there. So you can have things fail if you want them to, according to your business logic. Here's another example where we're going to have Alice send Carol $300. And this is going to appear to succeed, but when we go and look at what actually took place, we see this red line in the middle. So it did the withdrawal, and the deposit, that's red. It's indicating a failure. And if we click that, we can see down here, invalid account. So Carol closed her account, and so we took money out of the first account, but we couldn't deposit it into the second account. So how do we recover from that? We need to use the saga pattern and have a compensation that reconciles the balances by putting the money back into the original account. And so inside the code for the workflow, you can see down here, we have a begin and a rescue. And so inside of that rescue, if the deposit failed, we can recover by refunding the money. And so we can control that logic and make sure that everything happens. Even when something goes wrong, we can control what takes place. Another problem that you might have is inside of your code, inside the activity, this file here. Let's say that you have a bug inside your code, so you're going to divide by 0. So there's a failure because you have a bug in your code, and I'm going to redeploy this. And over here, I'm going to do go back to Alice sending Bob $100. And so if I go back to the Temporal UI, we can see that it's running and it's failing. It's on attempt number 4. And if I scroll down, I can see, oh, we've got a divide by 0 error. And it even tells us in the stack trace right here, it's activities.rb line 26. And so let's assume that we didn't know that's where that problem was. Well, look at there, line 26. So I can uncomment this, fix the bug, right? And then I'll redeploy the update. And now it completed right then, and if I scroll back up, it's completed. Because on the next attempt, it's doing that reattempt with the updated code that has the bug fixed, so it's able to get beyond that. So you can fix live bugs in a production system. Not only does it identify where the problem is to tell you what you need to fix, then you can fix it and deploy that. And then the final thing I want to show is, let's say that we are going to send $50,000, and I've coded this so that amounts above a certain size require manager approval. So sometimes in an application, you'll have a human in the loop sort of thing, and Temporal supports that. And so if we look at what's happening, it appears there's no activity there. The withdrawal took place, but the deposit hasn't happened yet. And if we look at call stack, it tells us, oh, workflow.rb, line 41, is where it's stuck. And so if we look at workflow.rb, line 41, That's where we have a wait condition. So you can wait on some condition for an infinite amount of time, wait on something to resolve to true. And in this case, it's waiting to see if the transfer has been approved yet. And so this is just a Boolean value that's defined at the top of the file. Right here in initialize, I say transfer approved equals false, and then a little further down, I say if the amount is less than $500, let's approve it automatically because we don't want to waste the manager's time on something routine. But for a large thing, you know, there might be anti-money laundering or know your customer sort of rules that require us to wait for that to be approved. So how does this bit get flipped and how does the thing get unblocked? And the answer is at the very bottom, there's a special kind of method there that's annotated with workflow signal. And a workflow signal is just a way of sending a message in to a running workflow. And so the message we're going to send is we want to approve this, and we send the manager's name, and that becomes part of the log, and so somebody can look at it later. And this just flips the bit. And so I'm going to resize before I actually do the approval part. I'm going to resize this. Move this over here, move back to the history so we can see the thing running. And we're going to say that Jan is the person who's approving it. And by the way, this is a separate program. Just a few lines of code to send that signal. And this could be written in a different language than the main program. As soon as I approve this, you're going to see that thing completed. Boom. That's how quick it is. So you can implement human in the loop. You can block awaiting some condition. There's also a thing called a query, which allows you to inspect the internal variables of a program. So if you want to see like what's the current account balance or something, you could do that very easily. And so that's kind of it for my demo.